In this question, we've been given a table of points and two sign charts, and we're being asked to graph the original function f of x. So I went ahead and plotted the points, and now I'm moving to the first derivative sign chart. And that first derivative sign chart is going to tell me the local extrema, that's local mins and maxes, and it's also telling me the slopes of the tangent lines on the graph. So let's go to each partition point on this sign chart and see what information it tells us. So my first partition number is 0. When x is 0, what is happening? Well, if I put 0 into the derivative, it's telling me it's undefined. So I have two options for an undefined slope. Either the tangent line goes vertical for a split second, or there's a sharp point. Now, if there's a sharp point, there's either going to be a local max or a local min, depending on the direction of those tangent lines. And if there's not a local extrema, then it's just going to be a vertical tangent line. So when I look at my sign chart here, I can see that I have positive sloping tangent lines on the left. I have positive sloping tangent lines on the right. There is not a sign change, so it is not a local extrema. So I must be, my tangent line must be going vertical there. So let's sketch that in. I'm going to come over here to my graph at x equals 0, and I'm going to sketch a vertical tangent line. And I'm going to label that. I'm going to say the tangent line goes vertical here. Okay, moving on to our next partition number where x equals 1. If I put 1 into the derivative of the function, I'm told it's 0. That means there's a horizontal tangent line at the point where x equals 1. That means my graph is going to go horizontal for a split second. So I'm going to really emphasize that horizontal tangent line, and I'm going to mark here that if I put 1 into my derivative, it shoots out a 0 slope. So that's a horizontal tangent line, horizontal. Okay. And also when I look at my sign chart, I can see I go from positive slopes to negative slopes. Okay, so when I go from positive slopes, then I go horizontal and shift down to negative slopes. That's going to be a local max. So I have a local max at x equals 1, and I'll go ahead and label that too. That's going to be a local maximum there. Okay, and then my last partition number is 4. So when x equals 4, and I'm told the derivative is 0 there as well. So I'm going to have a horizontal tangent line here when x is 4. And then my sign chart changed from negative tangent lines on the left to positive sloping tangent lines on the right. Sign change means local extrema, and that is going to be a local min. So I'm going to mark that here on my graph. I'm going to have a local min at this point, because when I put 4 into the derivative, it hit 0. That meant my graph went horizontal for a moment. I'm going to really emphasize that horizontal part of the graph, even though it just happens for a split second. I'm going to emphasize it there. Okay, and that's a local min. So I've transferred the information from my first derivative sign chart about extrema and slopes of tangent lines here onto my graph. And now I'm going to move on to the second derivative sign chart, which tells me the concavity of the graph, or the shape of the graph. So I'm going to use the concavity to help me connect the points on this graph. So reading my partition numbers, I can see my concavity is changing at each of those partition numbers. So those are going to be my inflection. And I like to start in the middle here. So I'm going to connect x equals 0 to x equals 2. So that's this region on my number line from x equals 0 to x equals 2. In this region, I need to connect the dots concave down. Concave down. So I'm going to do that. I'm going to emphasize that vertical part of my graph starting here at x equals 0. And I'm going to go concave down till I hit x equals 2. Okay, and then my graph, let's start over here to the left, from negative infinity to 0. So for everywhere over here on my x-axis, for this entire region over here, I need to connect my dots as concave up. Now, a big mistake I see is students do this. They're like, oh, concave up must be a U-shaped graph pointing up. But then that would create a local minimum at x equals -3, and that's not indicated on my first derivative sign chart. So I do need it to be concave up, but I cannot create a local min there, okay? So instead, when I do my curved graph here, I'm still going to cup it, but then kind of go down forever. And I need to extend that end of my graph with an arrow because my domain is all real numbers. I'm told to assume it's continuous from negative infinity to positive infinity. Okay, so that region was concave up. And again, I need to do concave up here on the other side from x equals 2 to infinity. So picking up here to infinity, all this region needs to be concave up. So let's go ahead and connect that. And I have a min here at 4, so curving it up, and again extending my line with an arrow going up forever because of that domain being all real numbers. So there we go. Now that I've connected the dots with my concavity, I'm going to go back and just double check the tangent lines, the slopes of the tangent lines here. So I should have a positive sloping tangent line till I hit 0. So let's double check that that's actually happening. So my tangent lines are pointing up, 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 up till I hit 0 where it went vertical for a second. Okay, then I pick back up with those positive tangent lines and I can see I'm still going up. But then it's going to hit 0 again at 1, so it leveled off. Then my tangent lines should be pointing down next. So down, down, down until I hit 4. At 4, it's going to go horizontal. And then my tangent lines went up again, up, up, up. So I'm just kind of doing this to check my graph to make sure that everything is making sense, that I've all the information from the first derivative side chart is being represented, and all the information from that second derivative sign chart is also being represented. And just a word of warning, let's say, for example, on this little leg here, that you got kind of sloppy and you did a straight line. Okay, that would be major points off because it should be concave up. But if you drew that straight line and then you also wrote concave up there, I'd give you most of the points. I'd give you the benefit of the doubt that you knew it should be curved because you labeled it correctly. Same thing over here, you know, in this concave down area. If you had done some like straighter looking lines, that's not really concave down. But if you had labeled that concave down, I'll give you the benefit of the doubt, especially on a test, because I know test days, you know, we're nervous or we might be rushing. So I'm going to reconnect those with nice, pretty curves here. But yeah, just as a safety net, if you'll label those areas of concavity, that would help me out. Also, you can label those inflection points by labeling the important points like local extrema and inflection points. If you make a mistake, that will help me give you some partial credit. So there was an inflection point when x is 0, and again when x was 2. So the important information that I've labeled on this graph, I've labeled my local extrema, my local max, and my local min. I've labeled those inflection points. I've labeled the concavity. I labeled that my graph went vertical at a certain point. I really emphasized that vertical part of the graph, and I labeled it. And also with a horizontal, I really emphasized the horizontal or labeled it. It's not as important to emphasize the horizontal as it is that vertical. That vertical can be really subtle. Okay, so plot your points. Use the first derivative sign chart to label those local extrema and to label vertical and horizontal tangent lines, and then connect those points on the graph with the correct shape.